Let's continue graphing sine functions by hand. We're on example 5. A is 1. Okay, now let's look at this equation. It's a little bit different. We do have a parenthesis now. B is still 1. Okay. All right, our C value. Our C value is actually negative pi over 4. Okay, and D is 0. We don't have a constant. So let me say this about the C value. Okay, in the formula that we had, let me see if I can find those notes. In the formula we had on the introduction to graphing, I want you to notice that in this format right here, we have B factored out of X with parentheses around X minus C. In the formula, we have minus C. So how would we take the equation we're about to graph and make it have a minus here, X minus C? Because C is the value we're looking for that falls after a subtraction sign. Well, let's come back here. If you wanted to think about this equation as being y equals sine of X minus pi over 4, that returns to X plus pi over 4. We need an X and a minus so that our C value is now going to be negative pi over 4. Probably the quickest way is just to, when you find the C value, take the opposite of the sign that's in parentheses. All right, this is going to be a little more cumbersome than the multiplications that we've been doing with the first 4 examples, but we'll persevere. All right, how do we get to the new points? We take 1 over B. B is 1, yay, times X plus C. Well, plus C is plus negative pi over 4, so let's just return that to minus pi over 4, comma, AY, so 1Y plus D, and that's just 0. Let's clean this up. So we got X minus pi over 4. So now instead of multiplying, we're going to be subtracting to the X coordinates of the key points. And this is just Y. So all the Y coordinates will stay the same as the key points. So we're still graphing sine, yep. All right, using this formula, we're going to take all the X coordinates of the key points and subtract a pi over 4. So 0 minus pi over 4 would just be negative pi over 4. So think about how we're going to now be shifting the graph to the left pi over 4. We're going to have some graph to the left of the y-axis. The y coordinates stay the same, so I'll go ahead and record those at the same time I'm doing the x's. All right, what's pi over 2 as my x minus pi over 4? Well, it's just fractions, so pi over 2 minus pi over 4. Common denominator would be 4, so let's multiply this fraction by 2 over 2. We end up with 2 pi minus 1 pi, I guess. So we're going to end up with pi over 4. So we're going to get 2 pi over 4 minus 1 pi over 4, yes. So we're going to get pi over 4. Which makes sense because we're shifting the graph left. So left pi over 4 would put us at pi over 4. Got it. All right, what is a whole pi minus 1/4 of a pi? Well, a whole pi minus pi over 4, multiplied by 4 over 4, so 4 minus 1 is 3 pi over 4. That makes sense. To the left, a quarter pi would put us at 3 pi over 4. All righty. So 3 pi over 2 minus pi over 4. So 3 pi over 2 minus pi over 4. We need common denominator 2 over 2. So this is 6 pi over 4 minus 1 pi over 4. So I'm at 5 pi over 4. Negative 1. All right, so we could do 2 pi minus 1/4 of a pi, or we can look for a pattern with the other x's. So negative pi over 4 to pi over 4 to 3 pi over 4. I see the distance between consecutive x's is 2 pi over 4. So from here to here, that's 2 pi over 4. From here to here, that's 2 pi over 4. From here to here, I'm adding another 2 pi over 4. So if I add 2 pi over 4 here, I'm going to get 7 pi over 4. I just saw a pattern. I took advantage of it. Could you still do 2 pi minus pi over 4? Yes, getting a common denominator. All right, I'm just going to kind of look at spot check, eyeball my x coordinates. I do see I need a little bit to the left of the y-axis, so I might move my y-axis. I need a little bit to the left of the y-axis, I hope I said, not x-axis. All right, and let's decide how many tick marks to represent the distance from negative pi over 4 to 0. So, I don't know, 2. So let's call this negative pi over 4. So if this horizontal distance is pi over 4, then 2 more tick marks would put me at pi over 4. Oh, now be careful. Ooh, I hope this is good enough. I don't want to do 2 tick marks and label 3 pi over 4. So now I see that between these 2 consecutive x's, I have 1, 2, 3, 4 tick marks. Ooh, that might have been too wide. So if I count off from here 4 tick marks, 1, 2, 3, 4, that would have to be my 3 pi over 4. 1, 2, 3, 4. That would be my 5 pi over 4. I'm going to run out of room, so I'm going to have to come back and adjust. I cannot use 2 tick marks. I'm going to have to just use 1 tick mark. So 1 tick mark to the left is negative pi over 4. 1 tick mark to the right of the y-axis is positive pi over 4. Because the total distance between these 2 consecutive tick marks is 2, so I need to start here and add 2 tick marks, and this is where I can add my next x-coordinate of 3 pi over 4. Count 2 more, 5 pi over 4, count 2 more, 7 pi over 4. Okay, and then we'll plot. 0 here, 0 here, my midline points. Halfway between my midline points, 1, 2, 3, 4, halfway between them, I have my maximum. I'll let 3 tick marks along the vertical be a height of 1. This will be negative 1. Halfway between these 2 midline points is 5 pi over 4, and that's where I bottom out. Gets a little bit weird when you have a x value to the left of the y-axis, because you got to think about the tick marks between, not on either side of the y-axis, but between 2 consecutive x values of your points. All right, let's finish. Amplitude is the absolute value of a, that's just 1. All right, period starts at x equals negative pi over 4 and concludes at x equals 7 pi over 4. So if I subtracted these 2 values, 7 pi over 4 minus a negative pi over 4, so you can count it from the graph. That's a fourth, and that's 7 more, so that's a total of 8. So my period should be 8 pi, but let's use our formula. Our period should be not 8 pi. Our period should be 8 pi over 4, or 2 pi. So our formula says take 2 pi divided by b, and that is 2 pi. We're going to be pros at graphing these. Max is 1 and negative 1 for the min. All right, we didn't vertically stretch or shrink, and we didn't shift anything up or down vertically, so our range will be the parent function's range. All right, we're building. So now let's look at our most complicated example, number 6. All right, that's a busy equation, but using the strategy that we've been using should help us manage this. All right, Okay, there is a little hiccup here, so let's talk about this. Okay, I cannot say what C is until I factor out the 1/2 in front of X. I know B is going to be 1/2. I do know that. Here's where the little hiccup comes. C is not going to be pi, and that's because this coefficient on X is 1/2. So what I would suggest is in a problem like this, I would rewrite it. So y equals 2/3 sine. I'm going to put a bracket here. I'm actually going to reach in now here, and I'm going to factor out that 1/2 from X. So I'm going to put 1/2 here. That's my B value. Then the parentheses, like our formula. Okay, and then here I'll conclude the parentheses, and I still have the +2 at the end. So we know D is 2, but my target is C. C is not pi. Not when X's coefficient is not 1. So 1/2, I'd put an X here, because if I distribute that back in, I would get half X. I do have a minus. All right, now notice if I put pi here, if I distributed a 1/2 in, I'd get a 1/2 pi. Well, it's pi here. So what is pi divided by a 1/2? And that's what's going to go here. Well, I'm going to have to make pi divided by a 1/2 turn to 2 pi. Now let's check it. A 1/2 X, yep, back here. A 1/2 times 2 pi is 1 pi, and it is minus. Now we can identify our C value right here to be 2 pi. So remember, C is the opposite sign of what's in parentheses. And then it can't be C unless I have a coefficient on this X right here of 1. That means I factored out the 1/2. So again, like taking you back to these formulas right here, notice the structure of this equation. See how B's out front? And then we can identify what the shift is, left or right, or the C value. So like I said, that's a little hiccup there. We'll have problems to practice. All right, let's build the formula. So 1 over B, what is B? 1/2 times the X's plus C. C is 2 pi. Ooh. A, which is 2/3 times our Y, plus D. Oh, so sorry. D was 2. So plus 2. Ooh, we're going to be dealing with some fractions. Okay, let's clean this up. 1 divided by 1/2 is 2x plus 2 pi. And then I'll re-record this formula. This one's going to be kind of tedious. All right. I think I'm going to tackle the X coordinates and then come back and get the Y's for this problem, since both these formulas are a little more complicated than what we've experienced. All right, so the first X is 0, so 2 times 0, 0 plus 2 pi. So we're actually shifting our graph right 2 pi. So this period will start at 2 pi. I'll come back and get the Y's in a minute. All right, pi over 2, so double pi over 2. So that would be 2 times pi over 2 would be pi, plus 2 more pi would be 3 pi. This pi goes in for X, double it, add 2, 4 pi. I see the trend of the X coordinates. Perhaps you do too. It goes, the difference is a pi. So I want to say this is 5 pi without using these little formulas. And then this X coordinate will be 6 pi. Which suggests that the period would be the difference of these two X coordinates. This suggests when I subtract the bigger X minus the smaller X, I get 4 pi. And I do know when I take the formula for period, 2 pi and divided by 1/2, I will get 4 pi. So a lot of built-in check processes along the way. All right, let's tackle the Y coordinates. Oh, don't you love the zeros? All right, so when Y is 0, no fraction, that's just 2. So I'll come over here and get this Y coordinate, so that's still going to be 2. And the last one will also be 2. So those are your midline points, because we're shifting the graph up 2 based on our previous knowledge of transformational graphing. All right, so these are going to be the two cumbersome ones. So All right, so this is a current x of 1, or excuse me, y of 1. So we've got 2/3 plus 2. Common denominator, so 2/3 plus 6/3, which is 8/3. Where's it go? Right here. So I need to begin to think that, hey, that's, I need to kind of change that to a mixed number so I can graph it. So 8/3 is 2 2/3. So if you want to record 2 2/3, since we're graphing, that's probably not a bad idea. All right, -1 times 2/3, -2/3 plus 2. So -2/3 plus 6/3, which is 4/3. So when graphing 4/3, we'll graph 1 1/3. All right, the best we can. All right, before I place the coordinate plane, the x and y axis on here, I'm going to kind of see that my graph, at least this cycle of the sine graph, doesn't start until 2 pi. So I'm really going to want to put my y-axis to the far left. But also I see my lowest y value appears to be 1 1/3, and the highest y value is 2 2/3. So quite a bit above the x-axis. So I'm thinking I'm going to put the y-axis here, and perhaps the x-axis will be shifted down a little bit. Ooh, that was terrible. Notice that all your y coordinates are positive, so that's why I didn't leave myself a lot of room below the x-axis. Ooh, okay. All right, now we got to figure out the scaling. We've got to go from 2 pi to 6 pi, and I don't start till 2 pi, so let's see. I think maybe if I said, okay, each little block would be a pi, that means I'd start here at 2 pi, 3, 4, 5, 6. Maybe I can use two blocks for 1 pi. So 1 pi here, 2 pi, yeah, that'll work. 3, 4, 5, and 6. All right, so my graph's going to start at 2 pi, x equals 2 pi, but it starts at, not on the x-axis, it starts up here at 2. So we got to tackle how we're going to scale the, positive y-axis. So 1 1/3 and as high as 2 1/3. So if I count 2 blocks as 1, that's 2, and that's 3. That might give me some room to where it's not so crowded. So let's try that. All right, 2 pi 2. Midline point, 4 pi 2, midline point, 6 pi 2, midline point. So halfway between these two midline points, I'm going to peak out because my graph starts up. I don't have a negative here. And then halfway between these two midline points, I will reach my minimum. All right, so let's see, what do we need? 3 pi, which is right here, at 2 2/3. So 2 and 2 would be more than this, so it'd probably be about right here. That looks like about 2 2/3. All right, at 5 pi, which is here, we want to be at 1 1/3. So 1 is here. 1/3 would be less than 1.5, so it'd probably fall about right here. Got to do some thinking about, where those values are placed. Looks pretty good. All right, and let's fill in all the information. Amplitude is the absolute value of A, but that's already positive. Let's be, oh yeah, x equals 2 pi. Again, I could subtract these two x values and get 4 pi, or you can think of the formula 2 pi divided by b, and in this problem, b is a half, so that would give us 4 pi. What was d? Oh, we have none. There are no x-intercepts. Lovely. Oh, so much better than writing 3 ordered pairs. Woo! Okay, max and min. 8/3. And what's our range? 4/3 to 8/3. It's really been vertically shrunk. Well, that makes sense because the vertical shrink comes from the A value, and 2/3 is not 1 whole. So you're making the sine graph less than going from -1 to 1. Yeah, that makes sense. All right, now it's time to practice.